Welcome to the very first OpenRAG Summit. We're incredibly excited to share a whole new way to think about building RAG-based systems using open source. So thanks for joining us. We're broadcasting live from IBM's Silicon Valley Labs. My name is Carter Rabassa. I lead developer relations for the Open Agentic Platform team here at IBM. And for those of you who aren't familiar with RAG, the term was actually coined back in 2020. There's a pretty famous research paper by Patrick Lewis. And there were some researchers that figured out how you could marry or combine data with very, very early LLMs to build intelligent systems. In their case, they proved that you could build a dense set of vectors based on Wikipedia data and marry it with some machine learning models to provide intelligent answers. And this was all the way back in 2020. Personally, like my first direct experience as a developer and as an engineer building with RAG was when I joined DataStax. So DataStax was a company that had built a vector database called AstroDB. And I joined DataStax in late 2023, and that was my experience using RAG to build, at that time it was a chatbot. But what was really interesting about it was that I've been a full stack web developer for the better part of my career. And the idea of using information from a database to create an experience for an end user is what all full stack developers have been doing for decades. So RAG felt really, really natural to me. And it was delightful to see how you could use a lot of the same ideas and techniques to create not just chatbots, but really intelligent software. So thanks so much for joining us. We are going to go ahead and kick things off with Charna Parkey. So Charna Parkey leads our agentic knowledge team here at IBM. And she is going to share with you what we've been working on to make it easy for developers to build systems using RAG, using open source and open platforms. So I'm going to go ahead and turn it over to Charna, and she is going to kick us off.
Hi, I'm Charna. Thank you, Carter. I'm so excited to show you what we've been working on. It's a first look. You are all the first to see this. So I know that if you're here, that you're interested in building with and on open source technologies. So today we're going to explore building that next generation of RAG like Carter was talking about, and we're going to use all open technologies. And this is a code first event, so I only have 2 slides for you before we get into the code. So first I want to say, as developers, we know open lets you build on top of it, and it's not enough to have a black box, right? And so these components that you see here are what's under the hood. We have Langflow for orchestration, OpenSearch for retrieval and storage, and Docling for the document processing. And what OpenRAG is doing is stitching it all together, right? It is very hard out there to start from scratch. There are too many options for RAG. What on earth are we going to do with this database or that database or this embedding model or this model provider, right? It's very difficult when you start from a blank page to say, this is going to work for me, or I can see immediate value. So that's what we decided to fix. You can quickly get started, and you can swap all of these different pieces. You can extend all of these different pieces. But what we did is we said we're going to standardize on OpenSearch. We're going to use Docling for this document processing, and we're going to leverage Langflow for all of the orchestration because it's going to make it super simple to get started and build on top of. So, like I said, I'm not a fan of too many slides, so I'm just going to jump into it, right? Let's go ahead and switch on over. This is the terminal UI. I could start this from a bunch of Docker containers if I wanted to, but I'm actually going to just start them all like this. I've got 5 containers running on my computer. I have the OpenRAG front end and back end, OpenSearch container, and a Docling serve native service running here. So that's all I needed to do to get started, right? Once you've got it installed, you're up and running. I'm I'm going to go ahead and go to OpenRAG. It's going to configure things under the hood. We're getting started. All of these different containers have different sort of like run times and wait times. OpenRAG knows to wait for these different pieces to get ready. And so as we get started, the first thing we see is an onboarding flow. You can skip it if you want, but don't worry, it's only 3 steps and it helps you get things configured. So the first thing I need to do is get my Anthropic key. I have a number of choices that I can make here. I can choose to run the models that are local on my machine from Ollama. I can choose OpenAI models, Watson-hosted models. All of this is true, but I'm going to start with Anthropic. So we're going to set up my model provider. That's one choice I need to make. And we're going to set up my embedding provider. And because I already have my OpenAI key set up in my environment variables, it's fast. OpenRAG is ingesting some sample data right now because we want OpenRAG to know about itself, right? It's no longer okay for the systems that we use to not be AI native. So if I ask a system about itself, it should know. And everything that I'm showing you here is actually powered by the stack itself, so you can modify it. So when I ask OpenRAG, what is OpenRAG, it tells me. It's an open source package for building agentic RAG systems, right? I've got Langflow, OpenSearch, and Docling. I can click out into these different pages to learn more about each of these different technologies. And the reason I need to do this, right, is that you can do anything you want with any of these components under the hood. But I digress. I want to add my own document. I said from 0 to agentic search in 15 minutes or less. So let me pull in my first document. That completes my onboarding flow. It's processing my document that's local on my laptop. And we're going to drop right on into OpenRAG. I can now start chatting with that document, right? I can say, you know, what is IBM and Anthropic position on the agentic development lifecycle? And this is actually going to go search. It's going to talk to my agent. It's going to go search in OpenSearch. It's going to summarize the different chunks that it gets back, and it's going to tell me about that data that I just uploaded. It tells me, you know, exactly which source that it used and what query that it used. And all of this is open and extensible. So I can see what data I have in the background when I switch on over to Knowledge. I can click into each of these pieces and see the various chunks that are actually being stored in OpenSearch. And all of this data is being powered by OpenSearch. If I had a large repository of documents, I could search for something here, like formats. And I could get to a set of chunks with the various average scores of what actually matches the search that I'm doing, right? So nothing is hidden from you. OpenRAG's front end is just a view on top of all of these different pieces. And when I want to dive deeper, I can. So let's go on into settings. In settings, you know, I did the most basic setup. All I did was I set a password for OpenSearch and I gave it some API keys. It doesn't stop there. We have a set of connectors that you can use. You can set up OAuth with Google. You can connect to Google Drive. You can pull in from SharePoint. You can do OneDrive and S3, of course. But I'm just in this basic configuration. So if I want to do that kind of thing, I'm going to need to configure it. If I want to configure more model providers because I want to compare between these different pieces, I can do that too. And if I want to click in to any of the pieces of this component stack, I absolutely can, right? So all I did was I clicked on the agent, and I'm now in Langflow. I can see all of the pieces. I can see my agent, the fact that Anthropic is selected. All of the pieces that are inside of the OpenRAG UI are also in Langflow. So when I make the modifications, I want to add a data source, or I want to do something else like that, all I have to do is drag those components into the canvas, and it's automatically going to update in OpenRAG. And it's not just the retrieval flow. You also have out of the box every piece of the UI that's being powered by Langflow, right? Those nudges that I'll go show you in a second in the chat, it's just a flow. So when you're making modifications to these things, think about this as your reference stack for an agentic Gen AI app that you can build and you can extend. So let's go on back into OpenRAG. This piece here is just a simplified view of the more complex components that you can modify under the hood. The same is true for ingestion. So if you're ingesting some more complicated data, you can turn on OCR or picture descriptions, and you can make a trade-off between fast ingestion or actually extraction of these different pieces. And oh, by the way, everything under this is powered by Dockling, and you'll see that a little bit later in one of the other talks. So let me do something interesting. I'm going to add some more data here. Maybe I will add some data about a question that I often get asked, especially whether I'm in product or engineering, and I bet as an engineer you've been asked this as well. What happens if I need to scale up, right? Everything is about, cost these days, right? How much is it going to cost if I have more users? How much is it going to cost if I change my plan and we can drive down the cost of operating this? So I've got some example pieces of data here. I'm pulling these in. I've got my roadmap of what's coming, my pricing policy, various pieces. They're being ingested from local on my machine. And like I said, you're not fixed to local here, but because I don't have my connectors set up, I'm only seeing file and folder. If I were to have Google Drive, it would be syncing with Google Drive. So I've imported my data, and now I want to set a set of knowledge filters, right? I now have multiple sources of data. Maybe I want one that only talks to my docs, and I want those sources to be, my OpenRAG documentation, Docling, and the Kuga agent inside of Langflow. I'll create a filter and allow for enough chunks to come back so that I can actually get all of the various pieces of my documentation. That should allow me to separate when I'm talking about my documentation and when I'm actually going to show you this other piece of estimating the cost. So let's go on back to chat. I'm going to start a new chat here. And one of the things I want to do is actually copy what I want the question to be, because you do not want to see me type this long sentence. But what would our estimated monthly cost be if we scale to 65 million tokens per month? Use our standard enterprise pricing. So it's going to need to know. Don't just go search the internet, but search my data. And it's more than just search, right? When we're talking about agentic, it needs to decide what information, and it's telling me, I need to find information about the pricing, and then I can calculate. Okay, I found that your pricing is this, and now I'm going to do some calculations, right? So we start to see these agentic pieces when I add more data and I ask more complex questions. I see that it called the search function, and I see that I called the evaluate expression function. It's because out of the box, it's coming with a calculator, as well as connection to OpenSearch, right? So based on your standard enterprise token pricing, this is what it's going to cost, $3,250 per month. And it's coming from my pricing policy, not some generic pricing policy on the internet. So I want to show you a few more things before I hand it over to our next speaker. The first is, I told you a little bit about those filters, right? So let's go on into my what is OpenRAG conversation. I can actually apply this filter here inside of the chat. And what's really cool is that when I now ask it a question about what is dockling, and of course I typoed that. This is why I didn't type that last question, because I'm not so great at this. So here we go. I'll search for information about dockling. I found information about dockling, which is great because, if I could ever type this correct, it would be great. And it gives me an initial set of information. And then when I'm actually getting the next set of suggestions here, those nudges are also powered by my filter as well. So it's not going to just suggest that I do things from other conversations. It's going to suggest that I can use the next step in this conversation. So like I said, this is part of what comes right out of the box. You don't have to build this agentic retrieval system. You don't have to set up all of these, which model, et cetera. It's going to decide for you out of the box, and then you can make changes if you want to. So let me switch back on over. I have one more slide to show you, and that is this one here. So like I said, this is a first look. We are signing folks up for our private preview. Scan the QR code, go to the website, input your email, and as soon as this is ready, as soon as we actually put all of the fit and finish on it, we'll give you a call, we'll give you access, and we'd love your feedback.
Awesome. Sharna, thank you so much. I'm so excited about OpenRAG, and I hope you all have a chance to sign up for the preview and get to play with it. I remember when I started at DataStax back in 2023, This is really just when RAG was starting to kick off in a more mainstream way. And it was the beginning of developers trying to figure out, like, what are the right tools to use? Like, how do we optimize for the best experiences? Which vector database should I use? What framework should I use? And those were amazing times. It kind of reminded me of, once again, kind of going back to full stack web applications. And like, I remember when Ruby on Rails came out, and like what a lodestar that was for web developers all over the world, right? It was open source. It was built on a pretty cool language at the time that was relatively new. But what was great about Ruby on Rails is that it freed the developer from having to sort of like make too many choices that were separate from the actual experiences and applications that they cared about, right? I know as an early Ruby on Rails developer, like I knew what kind of app I wanted to build, and I didn't want to think too hard about exactly like how to write the query or how to configure the ORM. And I think that that's what's so exciting about OpenRAG. It's like I said, like the paper, the OpenRAG was coined in 2020. It's 2025, right? So there's been a lot of maturity in the space and in the stack that developers and engineers are using to build these RAG systems. And we think that OpenRAG is like a really fantastic bundle of open source technology that you're going to be able to use out of the box to do most of what you want to do. But because it's based on open tools and open platforms, it's completely accessible to you as a developer to customize and change and tweak, right? There are no black boxes here. You can have it do what you need it to do. I'm going to turn it over to our next speaker, Roy Dirks. So Roy Dirks is going to give you a little bit more of an in-depth tour of dockling. I think me and a bunch of the folks on my team, we first started playing with dockling about 6 months ago. And we had used a lot of other ingestion and pipeline frameworks and tools before that. And we've just been incredibly impressed by like what dockling offers, how easy it is to use. And we're super happy that it's a built-in part of what we're shipping with OpenRAG. So with that, I'm going to turn it over to my friend Roy Dirks, and he's going to tell you all about what you can do with dockling to make it really easy to ingest all that unstructured data that you care about and make it something that's useful inside of your applications.
Awesome. Thank you, Carter. And thank you, Charna, for a great OpenRAG demo. My name is Roy. I work in product and engineering here at IBM. And I'm going to show you what you can do with dockling, which is one of the key components in the OpenRAG demo that you saw. So as you're building these AI applications, or maybe you're building agents, or maybe you've dabbled with RAG in the past, the one key thing you would need is to turn your data, whether it's structured or unstructured, into something LLMs and agents can actually work with. So dockling is really great at helping you to turn that data into something you can plug into your AI application or your agent. It can work with all sorts of files extensions, and it can also output JSON, Markdown, or even plain text. There are a lot of things you can do with dockling. I can talk for hours about all the features that are in there. There's quite an extensive list here or on the GitHub page because all of it is open source. But I want to spend some time on how to actually use dockling as a developer. There are a couple of ways to use dockling. You can go to GitHub and check out the Python code. You can pull down the source code. You can go to PyPy and install it directly using pip install dockling. That's one of the key ways to use it. Another way, which I personally really like, is using the MCP server, because you can use this MCP server in your chat application that also supports bringing in MCP servers. So if you want to use the MCP servers, you can just do it by using UVX. And then finally, there is also models. So dockling is more than just code. It is also models that help you to turn that data into something you can use in your AI application. And all of this is integrated in many great already existing developer tools like Langflow or Crew AI. We also have partnerships with all sorts of companies like NVIDIA to improve dockling as well. So there's many ways to get started as a developer, and I'm going to show you a couple more. But first, I also want to highlight that dockling is really great at turning these documents into structured data. The people at Hugging Face did some tests and actually found dockling is up to 50 times more efficient than using a vision model directly. And you can find all of this if you search for it. There are data sets you can try out with Docling yourself. I can show you more numbers, but probably the best way to actually figure out if what I'm telling you is correctly is by trying it out yourself. And we see developers massively trying out Docling on their own. If you look at the GitHub repo, it has a ton of stars. It has been one of the trending repos on GitHub as well. You can also find it in the trending data sets on Hugging Face. As I mentioned, Docling is more than code. It's also models. And we have over 2 million downloads on Hugging Face and PyPy combined. And I can tell you much more about Docling, about the team behind it at IBM Research that is building it, on how we work together with the Linux Foundation, or how it integrates into all sorts of developers' products. But I can also just show it to you. So the next part is going to be a quick demo on how Docling is powering OpenRAG, but also how you can use Docling yourself, either via MCP or by using it directly in Langflow. So we just saw OpenRAG. A part of a RAG pipeline, of course, is ingestion. And I'm actually going to go back here real quick. If you think about RAG, it's two pieces. Basically, it's retrieval and ingestion. The part that Docling can help you with is the ingestion part. So I'm going to show you an ingestion flow that's being used in OpenRAG today. And then we're going to highlight how Docling is powering this ingestion flow by parsing documents. So this is the ingestion flow for OpenRAG. If we go to the very top, you can see Docling is in here. We're running Docling. We're running Docling serve, meaning there is a server that has Docling running, and we can send documents to the server. And then we're going to export this as a Docling document. So what Docling does, it doesn't directly transform your data into plain text or Markdown or JSON. It turns it into a Docling document first, and this document can then be translated into different pieces of structured data. If you look at the rest of the pipeline, it's all going to help you by taking these documents, doing some conversions, splitting it and chunking it, and finally storing it in OpenSearch right here. We have other speakers showing you later how to do this step by step. I'm just going to highlight the Docling part. For this, I'm going to open a different flow, which is my Docling flow. And in here, you can see I have Docling serve running again. It's running on my local host, but you can also deploy this to your own servers or run it on your own machine too. And then we're going to export it as a Docling document. We can have different export formats. We can do Markdown, HTML, JSON, even plain text. If you want to do more, you can actually click on this component here and set more settings. There are plenty of things you can do. And finally, we're going to output the results of this. So the file I'm taking is actually a research paper about Model Context Protocol. I'm a big fan of MCP, and I think more developers should use it. Developers are already using it. If you look at Carter, he has a nice MCP shirt. So luckily, I'm not wearing the same one today, otherwise it might have been weird. So this is the paper I'll be looking at. It has text, which is easy. There are plenty of ways to turn text into text you can use in AI apps. It also has diagrams. So most document processing tools, they struggle with these diagrams. And they might also struggle with tables. Whenever you combine a table with a diagram, all of that sort of more complex setup you might see in PDFs. So in Docling, I already turned this file. I already uploaded this file in Langflow here. You see I froze this component. I can actually look at the exported data. So let me run this export pipeline. And now I'm able to see my PDF being translated into plain text, or this more looks like Markdown. You can see there's a lot of things in there. If you would scroll down, you would find your graphs, you would find the tables, you would find all the information that's in the PDF. So something Docling does really well compared to other libraries is, if you look at PDFs, PDFs can be big, they can have diagrams, they can have tables. A lot of the PDF parsers that you might be using, especially lower level ones, like a simple Python script or a JavaScript script you might run, they don't really include page headers, they don't understand tables, they might not be able to parse your images into text, and they might be also quite noisy and unfit for most cases. If you look at Docling, you're able to do all of this. We saw before it's up to 50 times more efficient than just using a vision model. So if you were to drop these PDFs into your favorite chat application, you probably get good results, but you don't get the best results or the most efficient results. So this is where Docling comes in. And as a developer, there are many ways to try out Docling. So let me see if I can run this live. To be frank, it isn't my computer. Mine just broke down right before. So this is kind of playing with fire. It looks like it's doing something. Let me unblock the freeze, and then we can just pray together. Otherwise, I'm going to go back to my slides and show you how to try out Docling yourself. So this might take a couple of seconds depending on the speed of your machine, because it's going to parse this PDF. It might run a local model as well while it's doing all of this. And then finally, your output should be data that you can actually read, and thereby a large language model or an agent can also read. So I think I'm going to wait a few more seconds, and otherwise I'll just recommend you to try this out on your own at home. There we go. So now we have our data. If we go here, you can see the Docling document that's being created. It has my file name. It has a lot of things in there. It's not in data that we can actually read, so this is still JSON. That's kind of messy. So that's why we export this Docling document into something like Markdown or JSON or HTML. I'm actually going to try Markdown again and then run this part of the pipeline, and then we should be seeing fresh data coming in. You can see it's taking slightly longer because previously I froze this, meaning that, well, actually should have frozen it again because now it's going to run the entire thing again. So I saw Carter being happy. Maybe we need to do another dance in the meantime. I think it took like 40 seconds previously, so we can wait 20 seconds.
We have time.
We have plenty of time, people. We have like 2 hours full of demos for you. So yeah, I'm running this pipeline now. It's going to export it as Markdown. I could have went with JSON or plain text. I think I should have JSON in here somewhere as well. So now if I'm going here, I can see fresh data, and this is all running on the fly. And you can do this with basically an unlimited amount of documents. And if you install OpenRAG, eventually you're going to be able to have an easy way to bring in all sorts of files, even have files running from a directory, all these kind of things. So Docling is really helping you to simplify your RAG pipeline by taking away the hard part of turning these documents into something your AI apps can actually read. There are many ways to try it out yourself. So there are a couple of QR codes. If you want to look at the docs, you can follow this QR code, which will bring you to the Docling website. You can also try out the MCP server, which you can use in any chat application that supports MCP. It's even natively integrated in the connectors page in Cloud Desktop. And then there are the models on Hugging Face in case you want to try those out. If you're lazy like me, you can also just go to your terminal, run pip install Docling, and see how to run it yourself. So thank you.
All right. Roy, thank you so much. By the way, if you don't know how scary it is to do a live demo on somebody else's laptop, then you haven't experienced true fear, especially when you're doing it on camera in front of thousands of people. So thanks so much, Roy. Dockling is really amazing. I know during my early days of just trying to build my first RAG applications, there was just this like horrible pain and struggle of figuring out like how am I going to take all of this unstructured data, these PDFs, these Word documents, and turn them into things that were actually useful in a RAG setup, right? And I tried just about everything, and I've just been really impressed by what the Docling team has put together. I remember the first time that someone sort of walked me through Docling and actually talked about the fact that they were using small models like during ingestion, right? I mean, it completely blew me away. It wasn't really even a use case for models that I had considered. I came into AI engineering through a bit of a large language model lens, starting with OpenAI and branching out into all of the technologies that we're super familiar with. Lately, I've developed an amazing appreciation for smaller, purpose-built models. that in Dockling's case can help you, can be the difference between understanding a PDF or not. But then just once again, as an application developer, now that I kind of understand what a small model is and how you can use them, you can really start to imagine like how it changes how you think about building applications and like where models can fit into that process. And the other thing that is really great about Dockling is they've got a lot of sane defaults. So once again, going back to the Ruby on Rails metaphor, or pick your framework of choice, maybe something like React, right? Like it's important to have sane defaults. For 80% of developers, you don't want to think too hard about how your unstructured documents are being ingested. You just sort of want it to work. But then once again, you want to have the power to go in there and configure things, tweak things, customize things, because there's just a large world of use cases that developers are trying to solve for. So we are now going to transition to our next speaker, Rin Whitna. Rin is a technical lead for AI ecosystem here at IBM. She's going to talk about OpenSearch. So here's a misconception about RAG that I hear all the time. I hear that RAG requires vector databases. And I completely understand it, right? Because the internet is littered with blog posts and videos that sort of frame RAG as something that requires a vector database. And I think it's really important to understand that simply isn't the case, right? And it's in the name, right? Retrieval augmented generation. There's no prescription for where that retrieval happens, right? You can get contextual, relevant, useful data from anywhere, and you can use that to augment the experiences that you're creating with your LLM. In this case, as part of OpenRAG, we're standardizing on OpenSearch. So Rin is going to walk you through OpenSearch. It's super powerful, it's amazing stuff, and I'm going to go ahead and turn it over to Rin.
Thanks, Carter. So I'm Ren, and I'm going to be talking about natural language search with OpenSearch today. I'm also going to be talking a little bit about those small models, because the cool part about my demo is I have turned Wi-Fi off of my laptop. I'm going to be running it completely, including the large language model, on my computer. So this is going to be fun. So diving in, we're going to talk about OpenSearch. And OpenSearch in particular is a fork of the Elasticsearch line of products. So this was done by AWS a few years back, and it is a open core, community-first ecosystem around how do you do not only search and vector search and all of those great things that we need to do in the search ecosystem, but also provide rich dashboarding and things like that that are critical to being able to use this for other applications in your use case. So diving in, we're going to talk about keyword search, everybody's favorite tool of the early 2000s and 1990s. But keyword search is still an important part of any kind of search algorithm that we do today. And there's a traditional algorithm for this known as TF-IDF, or term frequency inverse document frequency. And it attempts to match documents based on keywords and the frequency of those keywords across the entire document set. So here's a quick example on the right-hand side. This is a set of words taken from Shakespeare's plays. And in particular, Romeo is a word only used in one of Shakespeare's plays. We see it in Romeo and Juliet, and we don't see it in the others. Whereas good and sweet appear in all 37 of those plays. So in terms of term frequency, we might see those words good and sweet used a lot in one of those plays, which might give us a higher term frequency score. But more importantly, since they're in everything, we're going to rank that a little lower because it's less unique across all of those different documents, all those different plays. And OpenSearch in particular uses a variant of TF-IDF called BM25. It's named after the Okapi Information Retrieval System from London. It's a best matching algorithm that kind of does the same sort of thing, but it's just a different weighting system. But it treats each document as a bag of words. So we're not preserving the context within those. We're not preserving the sentence structure. We just know, hey, this is all of the words that are present in this document, and we're going to match the keywords on those things effectively. But for some use cases, keywords aren't enough. So how can we go ahead and look at the meaning behind these things instead of just the text surface forms and how they appear? So this is where we enter the world of semantic search. We have data that's coming in, whether that is text or pictures or audio or video or whatever you have. And then we have embedding models that we'll talk about more in a moment that are specialized ways to take that data that you have coming in and turn it into a vector representation. Now, that's kind of a weird word, so let's talk about vector representations for a moment. So when we talk about a vector representation, it is a mathematical representation of the semantic representation of the text document or whatever else you have. So we start with tokens, right? We go ahead and in both approaches, whether it is keyword-based or vector-based, we break up all of our incoming stuff into tokens. So you can see here, this is a quick sample of breaking up things with a tokenizer. And a tokenizer will chunk up a particular piece of text into words or punctuation or other things like that that may be necessary to understand details of what's going on in it. And with that, you may have noticed using this in pretty much every search application you've ever used, right? When you go to a search bar in Google, it needs to do tokenization in order to break up the words of your query into different ways. And it might be just doing a simple white space splitting on the spaces in between words. And that works really well for English, but tokenization can be more complex for other languages where they don't use white space as a delimiter. But when we go through that, let's make a vector. So when we take a sentence like the cat sat on the mat, right, just a very simple sentence, we can go ahead and look at co-mentions of words that appear in that appear in that sentence with the word cat. So in this case, we see the word the twice. We see cat 0 times because it's co-mentions. We see sat once, on once, and mat once. So we've made a very simple vector of the cat as it appears in that sentence. And when we do this a lot of times, we have a lot of vectors coming in made from all of the text that goes into training one of these models, we end up with more of an average. Kind of the exact same way that we as humans understand words that we don't know, we look at the context of how it's mentioned. So in this case, I know the cat is some sort of object, I know it can sit, and I know it can fit on a mat. Like, those are all things I've learned about this. And that context, as you build it up with more and more data, starts to accumulate a much larger corpus and understanding of each of these words. So at its fundamental core, a embedding is a mathematical approximation of the semantic meaning of a chunk. So when we've trained a model, an embedding model, on all of this different data, so much data, that it can go ahead and have not just a first, like, one example, but millions, trillions of examples. We can go ahead and combine that all into combining that with attention mechanisms in the LLM to actually understand not only what does this mean, but what parts of those sentences are important. And it learns all of that by throwing more and more data at it generally. So we end up with an average representation that it describes the approximate semantic meaning of that chunk of text that was passed in. And this is where vector databases come in, where we actually go ahead and can represent in vector space the positioning of each of those vectors that came in, and we look for how similar those are to each other. So we might, for instance, pick one and say, okay, here are its 2 closest neighbors. Now I know how to do that. We do the same thing when we run a vector query, a semantic query. We embed it, we turn it into a vector, and we compare it against all of the existing ones to find its closest matches. And with that, we now have a set of documents coming back that are really helpful to us. But scaling this is always an interesting challenge, right? Because models get larger and embeddings get bigger. So the default embedding size from OpenAI, for instance, is over 1,500 dimensions. So in very large data sets, we have to think about how we maintain the search performance on those vectors. It requires a lot of detailed calculations. It requires some approximations. Sometimes you have to trade off accuracy versus size on disk or in memory. And we think that one of the most interesting ways of doing that is actually JVector. And JVector is a plugin that was written by the DataStax team a open source library written by the DataSex team, and there's a plugin that uses it for OpenSearch. So this plugs into the Lucene core of OpenSearch, and it provides a much more efficient way of doing large-scale vector ingestion and retrieval. So with this, it has inline vectors stored in the graph, so it can find those very quickly. It can kind of compress those vectors using selective quantization. And it can also, across multiple nodes in the cluster, it can do concurrent graph construction to make sure that it can go ahead and combine those together into an effective queryable graph in real time. Now, I'm going to dive into a demo. And as I mentioned, this is running locally on my machine. So you will see, first of all, that my Wi-Fi is off. And I am using Ollama, right? And I'm using the Granite series of small language models from IBM. And I love Granite, right? It's a really cool set of models using a hybrid Mamba architecture that goes ahead and it's a mixture of experts model. Hello, Granite. And it's running locally on my machine. So it'll take a second to boot up just because there we go. But anyway, so it knows that it is capable of doing some stuff. But you can see here that it doesn't know much about its world or its ecosystem, right? It knows that it's an AI language model. It's not a physical object or material. That's where RAG comes in. RAG is all about grounding these large language models in responses that make sense, that use real world data to make sure that those are efficient and accurate to what we're trying to do. So I'm going to go over to this little app I made last night, which is just a basic query interface. So I'm using for this, just as we saw in previous demos, I'm using Docling, and I'm using OpenSearch, and I'm using the OpenRAG pipeline for ingesting things into this. And then I can go ahead and customize some of that behavior. So for instance, if I ask what is Docling, it'll take a couple of minutes because I am running this locally on my computer. But the cool thing about this is I've gone ahead and made some tweaks to how it does retrieval. And I can do that because I'm able to access the underlying components that make up OpenRAG, which is really, really cool. It opens up the power of doing all of these things and giving me flexibility in terms of what things do I actually want to surface to my application. So here we can go ahead and see it's come back with an answer and says, what is Docling? And talks about how Docling works in OpenRAG. But the interesting part here is actually these right here that I've added, where it knows not only what document did those come from, but the line numbers it came from. And we can scroll down and we actually see all of the source documents coming back from OpenSearch here with scores and different details of what it found in those, which allows us to do rich analysis and kind of make it more grounded for the user, right? Make sure that they feel like, okay, I can trust this. I understand how this is working. I can see the data that it used to construct this question. Just very basic, but I was able to construct that in an hour, right, with the help of OpenRAG, and that's really, really cool. So diving back into the PowerPoint here, I want to show a couple more tips and tricks for this because I am a big fan of not just staying with what you can do out of the box. I want to expand this. I want to do cool things that don't come standard in every RAG application because I view RAG as like part of a larger system or larger application, right? It's something where you can come in and you can use it to expand out existing workflows. You can use it to ground techniques in when you're doing agentic workflows and combine that all together to make really rich use cases. So let's talk about filters first, where a filter is OpenSearch's way of going through and saying, hey, I don't want to look at all of the documents in here. I want to just look at a subset. So here's just a very basic query filter that will do, hey, I'm looking for only smartphones from brand A. Don't look at anything else when you do your query. And the cool part about this is these are combinable with pretty much everything else in OpenSearch. You can combine them with queries that do keyword searches. You can combine them with vector queries to limit the scope of what it's doing there. And you can combine them with aggregations. And aggregations are cool. Aggregations are the thing in OpenSearch that when you don't want to get documents back, but instead care more about getting an answer back, That is what an aggregation is useful for. So in this case, I want to know what the average price of all the products on my site are with tax. And it'll go through and analyze. In this case, it ran through over 4,000 different products on my site. And it said, okay, the average value here is about $75. And that's really good for me to know, because you can kind of keep an eye on that, and you can do it when you combine it with filters and you combine it with other aggregations. You can look at that over time. You can look at how that changes with different products and different dimensions. And you can use this to build really rich UIs for any sort of search use case. But let's get a little fancier. So this is probably difficult to see at the Zoom level, but this is also available in the OpenSearch documentation. But this is a combination of two queries. It is a filter query that is bucketing an aggregation. So it's saying, okay, I want all of the responses that were successful, a 200 success code, and all of the OS X operating systems to be two different buckets here. And then for each of those buckets, I want to know the value of how large the response was and average that, right? So you can go ahead and start doing multiple levels of this aggregation and see how they compound on each other, and you can combine it with filters, you can combine it with other things in order to get really rich responses back from your data. So one of the coolest things about OpenSearch is not just that it can do document search, it's that it can do metadata search. Right? It can go ahead and combine all of these things around vector retrieval with rich metadata that it can store in its document storage mechanisms in order to be able to filter on all of that at once. And it's really fun. I want to talk about one more thing, because this is kind of my favorite secret feature of OpenSearch, and it's the percolator. So you probably haven't heard of the percolator pattern before, because it's kind of a weird one. But this is an incredibly useful tool for building out rich applications that may have a different kind of interaction paradigm than what you're used to. So a percolator doesn't index documents directly. Instead, it indexes queries, where you go ahead and say, hey, here are areas of interest that I care about. And now I'm going to run documents against it, and if any of those match, go ahead and flag it for me. So this can easily turn into a proactive application, which is really cool for agentics, where you can go ahead and say, hey, not only do I want to be able to do this as a user-initiated pattern, I want to start being able to pull in information and proactively tell my user about the things that need to come up in it. So really cool, really exciting. OpenSearch is a great open source project. Really excited about the data stacks, JVector being included in it, and I can't wait to see what you build.
Awesome. Thank you so much, Ren. OpenSearch is sick. Sometimes, as a developer, when you're a hammer, everything looks like a nail. And I think for a lot of developers, relational databases, or NoSQL databases are their daily drivers. And there's no shortage of vector databases that developers have started to use to build these kinds of applications. But sometimes you really need something that's more purpose-built around search and building search-driven applications and systems. So it's just been really awesome to dive into OpenSearch and kind of look at all the, especially Rin is sharing all these knobs and dials that you're just not going to get out of the box with a standard vector database. So, and as a developer, those knobs and dials really help you imagine new use cases and new features that would have been really hard or really manual to do with a different kind of system. So yeah, just the more I play with OpenSearch, the more excited I get about it. I'm going to turn it over to our next speaker, David Jones-Gilardi. So David and I work together. He's a developer relations engineer on the Open Agentic Platform team. He's going to show you some awesome stuff about Langflow. But before we turn it over to David, what have we talked about so far? So you all got an introduction and a demo to OpenRAG itself. We then dove into the ingestion pipeline that is powered by Docling, and Roy Dirks helped walk us through that. Rin just showed us the search pipeline that developers and end users are going to use to actually get answers and get intelligent information out of the system. Langflow is the sort of beating heart that ties both of these systems together. And some of you might ask, hey, this sounds, this sounds a lot like products I'm already familiar with. Maybe like a Glean. Like there are certain out-of-the-box enterprise search products that you can buy and install and set up in your companies, right? But they're black boxes, right? There might be some limited degree of customization or tailoring that you can do, but ultimately it's a product and it's a black box. The difference with OpenRAG is that all of this is ultimately orchestrated and powered by Langflow. Langflow is completely open source. David is going to show you all the cool things you can do with it, but fundamentally, as a developer, you're going to be able to use it out of the box for the things that it's good at, but you're going to be able to dive in there and tailor things to make sure that whatever application or use case you're trying to solve for, you're going to be able to do. So I'm going to go ahead and turn it over to David Jones-Gilardi. He's going to have a bunch of awesome demos waiting for you. So let's go.
All right, thank you, Carter. And again, I am David. Now, we've heard from Charna, Roy, and Rin all about the various pieces of OpenRAG. And what I really want to dig into now is what happens when you want to expand on some of those pieces and maybe do some things that aren't directly in the OpenRAG UI. Okay, so if you're not familiar with Langflow, Langflow is it's a visual studio for developers. It's used to build agentic generative AI and RAG workflows in a low-code, no-code fashion. But there is depth for developers, and I'm going to show you a bit of that as we move forward. So why don't we go ahead and get into it. All right, so if you remember before, when Charna was showing the OpenRAG UI, I've got pretty much the same setup here. Now, what I want to do is I'm going to start having a conversation. If we take a look at the knowledge I have, though, I have some Wikipedia documents that I've ingested over a URL. I've got some stuff about the Flow podcast that we run, and some other general documents. But in this particular case, what I'm after is I'm building an application. And in fact, I'm building a D&D auto battler, like a retro D&D auto battler. So I'm going to use OpenRAG to actually help me in that process. So first thing I want to do, though, is I'm going to come over here and I'm going to ask a question. I'm going to say, what D&D monsters are in the latest manual? Now, here's the thing. I have not actually ingested any data about D&D into my OpenRAG system. So if you notice the response I get here, there's no relevant supporting sources were found for that request. So now this is where, if you can imagine, maybe I have data, disparate systems. I have data around my organization or data in different areas that may not be data that I can readily ingest. So how can I expand what I'm doing in OpenRAG to now add that data in and do it right now? So what I'm going to do is here in OpenRAG, I'm just going to go to my settings. Now, Charna was showing a little bit of this earlier, but I'm going to do something a little bit different. So you notice that both for the agent here and for the knowledge ingest, you have these Edit and Langflow buttons. I'm just going to click on this one for the agent. I'm going to open that up. And now I'm going into this flow. Now, real quick, before I do the fun part here, I do want to kind of explain what it is that we're seeing. I did mention that Langflow is a visual IDE that allows you to drag and drop components in. You're going to see me do some of that. It also has support for dozens of model providers. So where I'm using OpenAI in this case, Charna was using Anthropic earlier. There are literally dozens and dozens of providers with possibly thousands of models in them that you can easily drag and drop, and you can actually drop into one of these flows. It's the same thing for vector stores and other data sources, right? And you do that here on the left-hand menu. You see I've got all these types of things. I'm going to bring something over here in a moment. Now, if you look at the flow itself, what's going on here? The key thing really is this agent, and the agent is our brains, right? And notice that I'm tied into that same OpenSearch data. So again, this is the flow that is powering that chat experience when you're in OpenRAG itself. But remember a moment ago, I asked a question about those D&D monsters, and it wasn't able to give me an answer because I don't have that data in my system. So let's imagine now I have data in an external data source. I'm going to bring over my D&D store. So in this case, I actually have a vector store that I've got some data in. And I'll zoom into that so you can see a little bit more. And now all I'm going to do is wire this right up. okay? And if you take a look here, you'll see I have this information about the action itself. I have a slug, this D&D monsters. I've also given it a description. This is super important, by the way. Why? Because your agent needs to know what is this data for? What is this about, right? And so by giving it a good unique slug and description, you're giving the information to the agent that it needs. Now, I mentioned that this is the flow that's powering OpenRAG. So let's go back over here. I'm going to go back to OpenRAG, go back to my chat, and I'm going to say, do that again. And we see our little dog wagging its tail. It's going to go fetch stuff, right? It's fetching data. Boom, check this out. Notice now how you see this function call, this D&D monsters function call here, right? Where did it get that from? Well, remember, I mentioned that slug a moment ago. So our agent, our OpenRAG set up this agent, was able to determine, based off of the question I asked, what the actual monsters were and what the correct tool was. So now I was able to take external data that was not actually something I ingested directly into OpenRAG, and I was able to very easily add it right into my flow, and now I have that information useful for me. Now, okay, so I mentioned before that I was building a D&D app, right? And so why don't we go ahead and take a look a little bit more at what's going on there. I should also add, separate to things like just bringing in, like I did a vector store, Langflow itself actually has native support for MCP, right? Roy was mentioning MCP earlier. And why is this important? Well, for a couple different reasons. For one, now with MCP, the ecosystem of the various types of tools that I have available has significantly broadened, right? But then because of this native support in Langflow, it means that I can do something like this. Let's say I have other sources. So if I pop out of this project real quick and I look over here, I actually have a set of custom RAG flows. These are other RAG data that I've actually pulled in from other systems. These are all just kind of like other basic agents, right? One is talking to like LinkedIn job listings data. I have one that I ingested in a Riley book. And again, just looking at cases where I have external pieces of data. And because of the MCP support, I can literally just bring these in, pop this in the tool mode, and I'm going to say, you know something, I've already got the D&D stuff. I just want these two. Great. And now I can also wire that right up. And it would be the same thing too if I wanted to add, say, like a URL component, you know, all sorts of things, any kind of MCP component. I can do this kind of stuff. So I can continuously expand, if I want to, the types of things that my OpenRAG agent is doing. Okay. All right, so I mentioned this D&D app. So one of the things I'd like to do is we're going to go ahead and take a look at you know, just a very basic chat app I've built. So OpenRAG itself, the UI, you know, is just built. You know, it's a JavaScript app. You know, it's built using the call through Langflow with the OpenAI Responses API and things like that for good streaming. That's how you get these nice streaming interactions. But then as a developer, I want to do something like this myself, right? And so in this case, I've got this like basic Next.js app. You know, you could see up here, I could easily create, you know, something kind of similar to what Rin did earlier. You know, whip this up in probably like maybe an hour, right? That is essentially going through Langflow and it is interacting here. So if I then say, give me a table of the D&D monsters and compare them. Let's see. You see it's ragging there. There we go. Right, so I'm getting this, and again, this is coming from that recent data that I just added into my OpenRAG system. So this makes it easily extensible. But I mentioned a moment ago being able to then use this in application development. So yeah, having the chatbot is pretty cool, but we can do more, right? So I'm going to open up a little Easter egg here, and like I said, I'm making this retro D&D auto battler, right? And for those of you who aren't familiar with D&D, the lore is extensive, and there are an absolute ton of various classes and monsters and things like that. They have all sorts of stats and everything that go along with them. And from an application development standpoint, I'm looking for how can I leverage OpenRAG to speed up my development and make it so I don't make like simple mistakes on, say, the types of abilities maybe a cleric has or something like that. So if you take a look here, you'll notice that I have these buttons up top, this load classes from OpenRAG and load monsters from OpenRAG. So it's able to use the searches, kind of like what Rin was showing and Charna and stuff earlier, against this now compendium of knowledge I have, to then auto-generate all of the character classes and the monster classes based off of the information that it finds. And it's allowed me now as a developer, if I pop one of these open here, let's see, I go to the monsters, take the dragon, now it's a wizard, yeah, there we go, and I'll say, so now I've got these two characters here, and like the stats here, all this kind of stuff. This is actually coming from real queries into OpenRAG that allow me to develop with it. Now let's take this a step further. It's one thing to be able to pull from the data and like generate something like this dynamically, but what about when I'm coding? Well, if you remember before, I mentioned that Langflow has native dockling, or native, dockling support is native in Langflow, but native MCP support. So if I go to the MCP server tab here for any of my projects in Langflow, I have this ability to expose out my flows via MCP. And why is this important? Well, here I have these various tools. I can say, hey, I want the OpenRAG search agent, maybe the URL ingestion flow. And now I can come into something like Cursor or Claude Code or Warp or whatever, and I can configure it, right? I can come down in here and I can say, hey, I want you to talk to this thing. And you'll notice that whether I use the auto install or if I just take the JSON here, I can just literally put this in my config, and then I'll point it right to my Langflow instance, these particular flows. And now I've exposed OpenRAG to my Cursor agent. And where this comes into play, where this is actually coming into play with this very app, is now I can ask it questions. So as I'm working through my development and I am trying to figure out something maybe about dragons or something like that, and I want to maybe check something that's in my code, not only can I get information about it in real time, I can actually use that to build out some of the structures that are in my code with vibe coding, right? So it now means that I can leverage this OpenRAG knowledge directly into my downstream agents when I'm coding to help out my application development. And with that, I'll leave you with QR code for Langflow. So if you want to check out more, then just go ahead and scan that or bring you to langflow.org. And again, I cannot wait to see what everyone builds with OpenRAG.
Awesome. Thank you so much, David. So Langflow is a really amazing product. David and I worked together at DataStax, and DataStax was the company behind Langflow. So David and I, and obviously hundreds of thousands of developers have been playing with Langflow for the better part of a couple years. And it's been really amazing to watch the product grow over time. It's been really interesting to see what developers have been using it for, the kind of problems that they've been running into, the problems that they've needed to solve, and Langflow's been changing. As you can see, I'm a huge fan of MCP. MCP is completely changing how developers are building AI-aware applications. And Langflow is very quick and fast to support MCP. Super excited to see it function as the beating heart of OpenRAG. But we've gone through like a bunch of demonstrations of what these individual powerful open source technologies can do for you. And Charna sort of demonstrated how we've been able to package them into an experience for developers that we're calling OpenRAG. But there's a question that I think that we need to address as to why are we making such a big, what is the emphasis that we're placing on open technologies and open source? Why do we feel that this is so important? I know as a developer relations engineer that I care deeply about open source. I think many of you watching also deeply care about open source. And when you're building your applications and your systems, you are often prioritizing open source approaches. But I think it's important for us to sort of talk about why we've taken this approach. Because as much as we may like and prefer open source, ultimately we're all trying to solve problems, and we're all accountable to using the best technologies, techniques, and approaches to solving those problems for the enterprises that we work for. So I'm incredibly excited to be joined by Ed Anoff. He's the Vice President of AI and Data Platform Strategy here at IBM. And Ed is going to talk to us about why we are taking this open approach and really why it's the future of how we think that developers should be building AI systems at the enterprises that they work for. So I'm going to go ahead and turn it over to Ed.
Thanks, Carter. Very excited to talk to you today about this topic that hopefully is not controversial to all of you developers out there, which is that, open is definitely not just the preferred choice in terms of what we build on, but when we look at it over time, that, in general, that is what succeeds in the market. It's what people adopt, it's what they build on, it gives them the flexibility to get the things done that they need to. And so, as Carter mentioned, open is a key focus on everything you saw today. Many of us who are part of this effort at IBM joined this as part of DataStax becoming part of IBM. DataStax, of course, being one of the leading open source database companies. And what we learned there over the last couple of years was that developers were looking to take the flexibility that open source gave them, couple them with this new technology that we were seeing in terms of building AI applications, and figure out, how can I get into this? How can I build applications? How can I build experiences that really have impact in what we're doing? So the approach that we took around this was to step back and say, look, we've spent the last 2 years working with developers, working with hundreds of companies in terms of going and saying, how do we put knowledge to work within the applications we build in all the different forms, whether it's a mobile app that helps you figure out which restaurant you're going to go and have dinner at, or whether this is how you go and get to your internal company knowledge. And we said people are going to do this in a lot of different ways. It isn't just a one-size-fits-all. It's going to be built by developers like all of you. Needs to be customized and it needs to be flexible. And for that to happen, it needs to happen on fundamentally an open platform. And we looked around and we said, it seems like everyone else is going in a different direction there. You see all of these, let me build a RAG knowledge base, black box type of thing. And we said, really, if we were going to take this approach, if we were going to start from scratch, 2025, and go and address this, that we would go in a very different direction. We would go and say, how can we build this on open code? How can we build it on open models? Give you the choice of which models to use. How do we build it on an open ecosystem? Because I think everybody who's following this space knows that between 6 a.m. and noon, there are a dozen new announcements. It is a vibrant, flourishing ecosystem, a lot of innovation. And so, that took us in a couple of different directions. So one of the things that people have brought up is, vector databases, search, all of the different ways of getting at data and retrieving it. And we said, it really is a search problem. You need vectors, you need BM25, you need to bring those together. And when we looked at what developers were using, whether they were building in startups, whether they were looking at building in enterprises, what we saw was again and again, OpenSearch was the choice. And so one of the things that we announced this week, that I'm very proud of, is that IBM formally joined the OpenSearch Foundation, which is the governing body that helps innovate and drive adoption and direction within an open community. And IBM and DataStax made some contributions to OpenSearch. JVector, which is our disk ANN implementation, specifically designed for very high scale-out scenarios. It's what powers vector capabilities within Cassandra, and increasingly within that ecosystem it's being adopted, now available within OpenSearch. Dockling, you heard great things about dockling. Very, very widely adopted when you look at how people are building these types of applications. I'm not sure whether whether we mentioned it earlier, but it's been growing on GitHub, close to 50,000 stars now. By and large, the choice for going and intelligently taking apart documents and extracting meaningful data for these retrieval use cases. And then finally, Langflow, because building these types of applications requires you to customize the agentic loops. So these are open foundations, but equally important is the fact that they enable us to leverage the ecosystem, the thousands of projects out there that are delivering new capabilities every day built by many of you, as well as adapting it to what you're building and what you're innovating on. And so that's hopefully the takeaway that you saw today, which was we're packaging this up. It fundamentally represents what we think is a new direction in how to build these types of applications, built on top of the state-of-the-art industry standard for search, built on top of the orchestration tools that you're already using, leveraging the models that are able to go and challenge or able to deal with the challenging amounts of data that you're pulling in. It's been great to see what's been built. In a few weeks, you'll have access to this, and I hope all of you kick the tires on it, give us feedback, participate in it. This is the start of a journey for us that we hope that you all come along for. Thank you.
Awesome. Thank you so much, Ed. Man, I am so stoked. I can't tell you how long me and a bunch of the folks here at IBM have been sitting on this OpenRAG announcement, and it's just really great to finally get to share it with all of you out there. I loved what Ed had to say about why we're choosing to go the open route, right? Like why this is the right thing to do in 2025, right? I mean, there's a lot of directions that we could have gone in terms of like how to build and design these kinds of tools for developers. And I'm just really grateful that this is the direction that we're going, because ultimately, like, it's about choice, right? So you should be able to use the models you want to use. You should be able to plug and play all of these components as you like. But we really hope that you're excited about the system that we've put together. I want to thank all of our speakers for coming together and sharing not just OpenRAG at a high level, but all of the constituent parts with you, right? I want to thank Charna Parkey, who has been working tirelessly on putting together OpenRAG, really like leading this initiative, working across all of these different products to figure out like what is going to be like the best possible story for developers, both from the perspective of like how fast can they get started, but then how can they drop down into things and tailor things to meet their needs. I want to thank Roy Dirks. Roy is just one of the go-to people when it comes to talking about dockling, right? Dockling, as you saw, is just like an amazing tool. Developers love it. It's incredibly flexible. They've been doing super smart things with embedding models directly into these ingestion pipelines. Like, I love what I've been seeing out of the dockling team, and I want to thank Roy for sharing that with us. I want to thank Rin Whitna. So Ed and I and David, we come to IBM from DataStax. DataStax has been in the open source database, sort of community for a long time. Engineers at DataStax developed JVector. JVector is the sort of open plugin that Rin was able to demonstrate that's powering a lot of what you're seeing with OpenSearch. It's really wonderful to see investments that people make in OpenSearch that pay off over time, right? I don't know that when JVector was under development, the thought that it would find its way into something like OpenSearch was necessarily like on anyone's minds or roadmaps. So it's really amazing to see open source, kind of evolve in interesting directions and continue to pay off the investments that people are making. And I want to thank David Jones-Gilardi, who kind of hopefully gave you like an amazing look at what you can do with Langflow today. So like I mentioned, David and I and many other folks have been playing with Langflow for the better part of a couple years now. It's been evolving super fast. I love the fact that it is becoming that MCP is becoming just a completely native capability inside of Langflow. It makes it easy to build it into OpenRAG. It makes it easy to integrate into all kinds of systems that are outside of OpenRAG, and I really want to thank David for sharing that with us. So thank you for joining us for the first of hopefully several OpenRAG summits. We hope you're excited about what you're seeing. We were going to make sure to share a link with you that you can use to sign up for the developer preview of OpenRAG. Please sign up for it. We can't wait for you to get your hands on it, to get feedback from you. This is something that we're going to build in public, right? OpenRAG is built on top of open source, and it itself is open source. So once again, thank you so much for joining us, and we will see you soon. Take care.